In this second tutorial, we will list and use the 6 trigonometric ratios. So let's flip over to this page of our notes and we'll talk about the 6 trigonometric ratios. And we have a picture of a right triangle that I will label, and I will color code with 3 different colors if you want to grab some color right now. Theta, this is a symbol for the Greek letter theta, and we like to use the Greek letters for trigonometry. Theta is an acute angle. It's one of the 2 acute angles in a right triangle. And each of our triangle legs, remember there are 2 of them, will be labeled as either adjacent or opposite. And that, of course, depends on where they sit in relationship to the angle theta. I'm going to put theta right here at this acute angle in my triangle. It's always important to know where you're standing. Sometimes I actually put a little person here so I know where I'm standing and where theta is, which of the 2 acute angles I'm using. Because in relationship to this angle is where the opposite and the adjacent leg come in. Now, it doesn't actually matter where theta is for the hypotenuse. The hypotenuse is always the longest side. It's always opposite the right angle, and it's right here. I'm going to label this in red, the hypotenuse. That will always be where it is. The 2 opposite and adjacent legs depend on where I'm standing. So here's my theta. Opposite theta would be my opposite leg. So opposite theta is going to be right here, and I'll do this in blue. Here's opposite. And the adjacent leg, adjacent means touching, so the adjacent leg will be touching my angle theta, and here it is. I'll do this one in purple. So here's adjacent. So now I've labeled all 3 sides of my right triangle. Let's talk about our 6 trigonometric ratios. The main 3, sine, cosine, and tangent, are right here. The symbol for sine, they all have 3-letter symbols, is SIN. And then, of course, we always need some sort of angle. And right now, it's just going to be the sine of theta. The sine of theta is the ratio of the opposite leg to the hypotenuse. So let me get out my blue. The opposite leg to the hypotenuse. That's what the sine ratio will always be. The cosine ratio, the cosine symbol is COS, and then of course we always need some sort of angle here, so the cosine of theta. The cosine will be the ratio of the adjacent leg to the hypotenuse. So the cosine is the adjacent leg divided by the hypotenuse. And the tangent symbol is TAN, and then the theta. The tangent of theta is the ratio of the opposite leg to the adjacent leg. So the tangent would be equal to the opposite leg divided by the adjacent leg. Now, some people like to remember the sine, the cosine, and the tangent using the mnemonic device so, ka, toa, or some people actually like to write it like this, so, ka, toa. And what so, ka, toa means is the S represents the sine, and it's the opposite divided by the hypotenuse. And the ka, the C represents the cosine, and that's the adjacent divided by the hypotenuse. And the toa, the T represents tangent, and that's the opposite divided by the adjacent. So I think that this is a very helpful mnemonic device to remember those 3 trig ratios. The 3 main trig ratios, sine, cosine, and tangent, have the reciprocal trig ratios. And this is my symbol for reciprocal. If we take the reciprocal of each of these trig ratios, we have the cosecant, the secant, and the cotangent. The symbol for cosecant is CSC, and then our theta. This is 1 divided by the sine. So it is the reciprocal of the sine ratio. And since the sine ratio is opposite divided by hypotenuse, the cosecant would be the hypotenuse divided by the opposite, the exact reciprocal. We just flip it upside down. The cosine reciprocal is the secant. The symbol for secant is SEC. So the secant of theta is equal to 1 divided by the cosine, the reciprocal of cosine. And the reciprocal of cosine, well, if the cosine is adjacent divided by hypotenuse, then the secant is the hypotenuse divided by the adjacent. Okay, one more to go. The reciprocal of tangent is the cotangent. Cotangent's symbol is COT. Cotangent of theta is equal to 1 divided by the tangent of theta, the reciprocal of tangent. So if tangent is opposite divided by adjacent, then the cotangent is adjacent divided by opposite. So you need to memorize all 6 of these trig ratios. Really, you just need to memorize the SOHCAHTOA and then understand that you just flip them upside down to find the cosecant, the secant, and the cotangent. But you do need to remember the order here. So let's use these 6 trigonometric ratios and solve our final 2 examples. Let's look at example 4. The directions: find the missing side length in the triangles below, then determine the 6 trigonometric ratios of angle theta. Okay, so we have angle theta, but we're missing one of the sides. So let's just call it x. You can call it whatever variable you want. And let's use Pythagorean Theorem. The hypotenuse is 5, so I'll start with 5 squared, and that's equal to x squared plus 3 squared. So this is 25 is equal to x squared plus 9. Let's subtract our 9, and I'm going to start with my x squared is equal to 16. And of course, when I take the square root, I get plus or minus 4, but of course negative 4 is not going to be the side length for a triangle, so I will stop with the positive 4. So I now know my missing side. It is 4. And you probably already knew that because 3, 4, 5 is probably the most famous of the Pythagorean triples. So now that I have all 3 sides, I can find all 6 trig ratios. Let's find the sine of theta. Let's find the cosine of theta. Let's find the tangent of theta. The reciprocal of the sine is the cosecant of theta. The reciprocal of cosine is the secant of theta. And the reciprocal of tangent is the cotangent of theta. So these are my 6 trigonometric ratios. I encourage you to memorize them or list them in this order and remember the reciprocals in this order. That might help you. So here we go. The sine, if I'm talking about right here, maybe the star, or maybe draw a little person here, I'm standing right here where theta is. Sine is opposite 4 divided by hypotenuse 5, 4/5. Cosine, I'm standing right here. The cosine is the adjacent 3 divided by the hypotenuse 5, 3/5. And the tangent, here I'm standing right here, tangent is opposite 4 divided by adjacent 3. If you can reduce your fractions, you want to reduce your fractions, but I can't in this case. The reciprocals are exactly that. Just flip them upside down. The cosecant would be 5/4. The secant would be 5/3. And the cotangent would be the reciprocal of the tangent, 3/4. That's it. So we found the missing side, and we found all 6 trigonometric ratios of our angle theta. Let's do our last example and have some fun with our radicals. We're missing this side again. Let's call it x. I'm going to come off to the side and use my Pythagorean theorem. My hypotenuse is 10 square roots of 2. 10 square roots of 2 squared will be equal to x squared plus 5 squared. So there's my equation. Oops, I almost put 25. 5 squared. 10 squared is 100. Square root of 2 squared is 2. So 100 times 2 would be 200. 10 square roots of 2 squared is 200. X squared is x squared, and this is 25. Let's subtract our 25. And I've got my x squared is 175. When I take my square roots, I do not want an approximate. I want to figure out what perfect square is hiding in there, and I imagine that 25 goes in. 25 should go in there about 8 times. Oops. I'm pretty sure that's 7 times. There we go. So x is going to be 5 square roots of 7. We want exact answers, so that's what we've got, 5 square roots of 7. Now that we have all 3 of our sides, let's talk about our trig ratios. And here's our theta. Put a star, put a little stick figure guy. This is my theta. So I'm talking about, let's start with sine of theta. Sine is opposite 5 divided by hypotenuse 10 square root of 2. 5 divided by 10 square root of 2. So this is my answer. Unfortunately, this is not in simplified form because we cannot have a radical in the denominator of a simplified answer. So I need to rationalize. The square root of 2 needs to not be in the denominator. So if I need to multiply by square root of 2 to the denominator, I also need to multiply to the numerator. So let's see what happens here. 5 times the square root of 2, of course, is just 5 square root of 2. Square root of 2 times square root of 2 becomes 2, and 10 times that 2 becomes 20. And now I can reduce my fraction. 5/20 becomes 1/4, so the square root of 2 times 1, and 4 is down in the bottom. So our sine is the square root of 2 over 4. This is the simplified version. Okay, let's try cosine. The cosine of theta, here's theta, cosine is adjacent 5 square root of 7 divided by hypotenuse 10 square root of 2. So 5 square root of 7 divided by 10 square root of 2. We have the same situation here. I cannot have a square root in the denominator of a simplified answer. So I need to rationalize. I will multiply by the square root of 2 to the numerator and to the denominator, and let's see what happens. 5 times the square root of 7 times the square root of 2. Well, the 7 and the 2 are underneath the square root, so they will combine to make 14. The 5 does nothing other than be a 5. So 5 square root of 14. The denominator is actually the same denominator of 20. Square root of 2 times square root of 2 is 2, times my 10 becomes 20. And again, 5/20 reduces to 1/4. So there's 1/4, and then the square root of 14 is still up in the numerator. So square root of 14 divided by 4. There's my cosine. Some lovely radicals. And finally, my tangent. Tangent of theta would be opposite 5 divided by adjacent 5 square root of 7. So I've got my 5, and I'm dividing by 5 square root of 7. Now I've got a square root of 7 in the denominator that I do not want. So I'm going to multiply by the square root of 7 to the denominator and the square root of 7 to the numerator, and let's see what happens. 5 times the square root of 7 becomes 5 square root of 7. Square root of 7 times square root of 7 becomes 7 times 5 becomes 35. And then I can reduce 5/35, and I'll just do that right over here. 5 divided by 35 becomes 1 divided by 7, so the square root of 7 times 1 up in the numerator, and the 7 in the denominator. And that is my tangent. Whew. Trying to circle my answers here, my simplified answers. Okay, so that's half of it. Those are my three main trig ratios. Now let's do the reciprocals. All I need to do is flip those answers over, and I'll have my reciprocals. The sine, I'll put over here, the reciprocal of that is cosecant. Now I know that I can simply flip this answer, but if I flip this blue answer right here, I'm going to put a square root into the denominator. Now think about why we had to do all of this work. It's because this answer, which is our sine, had a square root in the denominator. What if I just flip this? If I flip this, then the square root won't be in the denominator anymore. It'll be in the numerator. 10 square root of 2 divided by 5 is the reciprocal of my sine. And that's even better because then I don't have to worry about the radical. Now I do have to worry about this. This is still not simplified. 10 divided by 5 can still be 2. And I'll get 2 times the square root of 2. Awesome. The reciprocal of cosine is secant. And let's see if we can do the same idea. Well, I could flip this answer, but then I'd be putting a square root into the denominator. Or I could flip this original answer, which honestly is about the same thing. Of course, I don't really want to have to deal with a bigger radical if I can just deal with this. So I'm just going to take the reciprocal of this. So 10 square root of 2 in the numerator and 5 square root of 7 in the denominator. Now I need to rationalize. There's really no way of avoiding it here. I'm going to multiply by the square root of 7 to the numerator and to the denominator. Square root of 2 times square root of 7 becomes that square root of 14, and the 10 is just on the outside of that. 10 square root of 14. Square root of 7 times square root of 7 is 7, times 5 is 35. 10 35ths can reduce by 5. There are 2 5s in 10, so there's still a 2 there. And there are 7 5s in 35. So 2 square root of 14 divided by 7 is my secant. And I have one last one to do, and that is my cotangent. I don't want to have to take the reciprocal of this. I'd rather just take the reciprocal of this original. So put the 5 square root of 7 in the numerator and the 5 in the denominator. That's going to be a whole lot easier because really all I have to do is whoosh, cancel out those 5s, and I've got square root of 7. So you can see building all 6 of our trigonometric ratios can have some good math involved with radical and rationalizing and of course Pythagorean. So thanks for watching this tutorial, and we will practice these methods in class. See ya.